So this is the question I didn't quite get around to finishing in class. It's the last example for related rates. So it's about a cat. So I Googled how fast does a cat run? Um, and it doesn't run as fast as I said it does, but yeah, almost that fast. So this is a really fast cat. So as with all related rates problems, we start by reading the question thoroughly. So a cat is running along the wall at zero point 0.5 meters per second. So, okay, that's a clue. That means that there is a speed, which is a rate of change. So position of cat is going to be a good variable. Maybe I'll start drawing this cat. So here's the wall. And I guess the cat's running along the wall. I'll draw the cat at a couple of times. So there's the cat at time 0. Now it's run along a little bit. So it's good to draw it at a general time because that's going to be how we get a general picture of what's happening. So that's the cat at time 0, and then the second cat is the cat at a later time. Okay, keep going. A spotlight is 4 meters from the wall. Okay, so presumably that means at a right angle. So that's going to be my spotlight there. So let's get that in the picture. And it's turning to track the cat. So this is some sort of rotating spotlight. So initially, time 0, it's looking that way, and it sort of rotates and it starts looking that way. And then in between, it's, turning to look at the cat. So the cat starts at a point on the wall closest to the spotlight. Okay, so that's good. That's where I drew it at the start. And maybe we can get in the business of writing down literally everything that it says. So this is the thing I haven't written yet. So this is 4 meters. I guess I can remember that the cat is running 0.5 meters per second. How fast is the spotlight turning after 6 seconds? Okay, so now we have to think about what it's asking us. So key phrase, how fast is, that's the rate in question. And how do you measure fastness of turning? Well, you turn using angles. So it must be how many angle units per second, which means a variable that's going to be important is the angle. So there's an angle, call it theta, whatever. And I guess the other thing I haven't really stuck in the diagram is this distance cat has run, which I'll call x. Okay, so let's draw a slightly pared down image. It's a right angle triangle, 4 meters there, x meters there, angle theta. And let's record what we ultimately want to know is we want to know the rate of change of the turning of the spotlight. So that's the rate of change of theta as t varies. And we want it at t equals 6. Okay, everything seems to be on the page now, and I can start analyzing what to do next. So remember, always the next thing to do is look at the variables you have. I've got an x and I've got a theta. Try and relate them by a formula. So this seems to be what I should be using. So the formula relating these two things is that the tangent of theta is opposite over adjacent. So that's x over 4. Now I've got my formula, I should differentiate it. So remember, all the variables are actually variables of time. So really it's theta is theta of t, and x is x of t. So now I hit this thing with some implicit differentiation. So d by dt tan theta must be d by dt, well, let me write a quarter x. It's a little bit nicer. So now implicit differentiation, I should differentiate the tan to get sec squared theta, and I pick up theta prime. So theta prime is d theta by dt. And here I'm going to get 1/4, and then I just get x prime. So dx by dt. Maybe I want to rearrange it to make theta the subject of the equation, because that's the ultimate thing that I want to see. But let me write it a slightly different way. So 1 over, so implies, I should be writing implies everywhere, cosine squared theta times theta prime, so that's by definition of sec squared, secant squared. And then that's going to give me my final formula that I want to try and solve. D theta by dt is 1/4 x prime cosine squared theta. So that must be how I'm going to get my eventual d theta by dt. So we're at the stage where we've got the formula. We just need to know whether we can actually plug in stuff to solve it. So I guess we didn't write it down up here, but the cat's running at a certain speed, which means x is increasing at that speed, which means we can input dx by dt, or in other words, x prime, is constantly 0.5. So we can plug that in. But there appears to be something we haven't worked out, which is cosine theta at time 6. So we've got to do it. Let's see. I'm going to take something to the next page. Let's take this thing. Oop. Yeah. So let's see. Cosine theta at time 6. So we want to know cosine theta. Well, actually, let's take stock. So what you might end up doing if you stared at this was, hey, let's work out theta. But actually, it would be enough to work out cosine theta. So that's, I think, going to be a little bit easier. So cosine theta should be adjacent over hypotenuse. So that should be 4 over hypotenuse. So we need to work out the hypotenuse, but in fact, to work out the hypotenuse, we also need to work out x. But x is just given by the speed times the time. Remember that x is just how far the cat's run. So what was the time that we're interested in? It was t equals 6. So it should be speed, which was 0.5 times 6. So we're going to get 3. So actually, x is going to be 3. And this is a classic 3, 4, 5 triangle. So I know that the answer here is 5. And I can either recognize that, or I can just do a quick check that by Pythagoras, 5 squared, well, let's see. If I want to work out the hypotenuse, it should be equal to the square root of the squares of the other two sides. So 4 squared plus 3 squared. So this is 16 and 9. So I'm getting the square root of 25. So that's what I would do if I didn't remember that there was such a thing as a 3, 4, 5 triangle. Okay, but that's looking pretty good, because now I know that cosine theta is 4/5. Okay, and now I want to sub it back in to my equation. I've got all the pieces now. So my equation is d theta by dt is 1/4 times x prime times cosine squared theta. So putting it all together, that's 1/4 times 0.5 times 4/5 squared. So that's 1/4 times 1/2 times 16 over 25. So I guess I should divide through by 8, and I'm going to get 2 over 25. So final answer, d theta by dt is 2 over 25. And I should get some units in there. So theta is an angle, so we measure it in radians. And the time was measured in seconds. So that is our final answer.